Hello and welcome to another MOOG demo library video. Today we're going to be exploring Spectravox. Spectravox is a unique device in that it straddles the line between instrument and processor, and for this example we're going to look at using it to vocode a Roland TR-606 drum machine. Now commonly vocoding is done with vocals, but it's not restricted to working with vocals and can apply to many other instruments, and so we're going to look at what it can do with a drum machine. So let's begin by listening to the dry signal that we have coming out of the 606. So you can hear I have a pretty simple, straightforward drum pattern coming out of it. And now let's take a moment and we will listen to how it sounds being vocoded by the Spectravox. I'm going to begin by turning Spectravox up. You'll just hear the oscillator droning, and we're going to be using the internal carrier oscillator. So now I'm going to flip the mode switch up to vocoder. And what happens when I do this is actually all of these connections on the front panel that show the envelope follower and the VCA CV are connected from the bottom jack to the top jack, but it's done behind the panel. And that's what happens with this vocoder switch. The way that vocoding works is there is a spectrum analyzer inside of Spectravox that's going to analyze the spectrum of the Roland TR-606, and then it's going to divide it into 10 frequency bands, and it's going to look at the volume information that occurs within that frequency band, and then generate a CV that will then control the volume of a filter band that we have on Spectravox. So let's now listen to how it sounds vocoding the 606. So you can hear I'm able to take the spectral information of the 606 and apply it to the carrier oscillator, making this single oscillator sound as if it was a drum machine. And if I were to remove any of the elements of the drum machine, we'll actually hear that in the Spectravox signal. So let's hear what happens if I remove the hi-hats. You'll also notice that I can move the oscillator around, adjusting the pitch. I can change the waveform. I could also mix in a bit of noise. And then, most interestingly, I can take the spectrum of all 10 bands and I can shift around where they're focused on the oscillator's signal. And it will move all 10 of the bands in parallel. So there's lots of interesting combinations to find between the VCO frequency and the spectral shift position. Next, we can actually increase resonance on all of the bands to add more of a metallic quality to the sound. And spectral shift will have a much more dramatic effect with high resonance settings. And we also have a built-in LFO that's able to modulate the spectral shift, so we could add some of that. Get some sweeping movement, that spectral shifting with all the frequency bands moving around. Now another interesting thing that we can play with is because we have outputs for all of the envelope followers for the different bands, we can actually rearrange which envelope followers are influencing which bands, and then these knobs that are volume knobs for each frequency band will act like an attenuator for that CV information. So let's say I want to take the envelope follower that is influenced by the kick drum and actually use it to control a band higher in my frequency spectrum. So I can plug it into. And then let's take the higher envelope follower that's influenced by the hi-hats or metallic percussion on the 606, and we can feed that into a lower band. can also use those envelope followers to modulate other things than the VCAs for each band. So let's take the second envelope follower and actually use it to modulate the pitch. Or I can try using a different higher envelope follower. I can also use it to modulate the spectral shifting. And this starts giving us almost like a formant quality with high resonance settings. We can also start removing certain frequency bands, or just reduce their volumes. We also have an additional envelope follower that applies to the entire program input. So it's looking at the entire frequency spectrum of the 606 and then generating an envelope follower based on all of that information. So let's say and then I can add a little bit of that LFO modulation to the spectral shifting. And one last thing that we can do is there is a switch up here that says band 910 hiss versus buzz. Right now it's set to buzz, but if I flip that to hiss, it will take the internal noise source and replace the oscillator just for bands 9 and 10. This can be nice when vocoding a voice to be able to reinforce some of the sibilant sounds that your voice makes with a bit of noise whenever those S sounds will occur. But in the case of this, it's really going to be affected by the hi-hats coming from the 606. So as you can hear, the Spectravox is a wonderful and unique way to radically transform the sound of an instrument that you're processing through it.